There are countless mysteries hidden in the depths of the vast universe, and the blue planet under our feet, the Earth, also has a puzzling mystery. Every day, the sun rises and sets, and the stars flow in the night sky, all accompanied by the quiet rotation of the Earth. However, where does the power of the Earth's rotation come from? Is it the mysterious power in the depths of the universe that is quietly pushing it, or is there an unknown mystery hidden in the Earth itself? Let us embark on this exploration journey to pursue the mystery of the power of the Earth's rotation. In the early days of the formation of the solar system, the original nebula gradually contracted under the action of gravity. Since the initial movement of the nebula material is not completely symmetrical toward the center, but has motion components of various directions and speeds, angular momentum is generated during the contraction process. As the nebula material continues to gather to form celestial bodies such as the Sun and planets, angular momentum is also distributed and transferred in this process. As one of the planets, the Earth inherits part of the angular momentum from the original nebula. The law of conservation of angular momentum states that the angular momentum of a system remains unchanged in the absence of external torque. For the Earth, after its formation, although it will be affected by various external forces, these external torques are relatively small and not enough to significantly change the Earth's angular momentum. For example, the Earth is affected by the gravitational forces of the Moon and the Sun, but these gravitational forces mainly produce tidal forces, which have a relatively small impact on the Earth's rotation and are not enough to change the Earth's angular momentum. Therefore, the angular momentum obtained by the Earth in the early stages of its formation has remained basically unchanged for a long time, maintaining the Earth's rotation. Angular momentum determines the rotation speed. Angular momentum is equal to the product of moment of inertia and angular velocity. During the formation of the Earth, the aggregation of matter gradually increased the mass of the Earth and also changed the Earth's moment of inertia. According to the law of conservation of angular momentum, when the moment of inertia changes, the angular velocity will also be adjusted accordingly. In the early stages of the Earth's formation, the aggregation of matter caused the Earth's moment of inertia to gradually decrease. In order to keep the angular momentum unchanged, the Earth's rotation speed will increase. This is like when figure skaters are spinning. When they retract their arms, the moment of inertia decreases, the angular velocity increases, and the rotation speed increases. Similarly, during the formation of the Earth, the aggregation of matter is equivalent to a decrease in rotational inertia, which leads to an increase in the rotation speed of the Earth. The angular momentum of the Earth not only determines its rotation speed, but also maintains the stability of the Earth's rotation. Due to the law of conservation of angular momentum, the Earth will try to keep its angular momentum unchanged during its rotation. Even if it is disturbed by some small external forces, the Earth will maintain the balance of angular momentum by adjusting its own rotation speed and rotational inertia. This stability allows the Earth's rotation to continue for a long time, providing a stable environment for life on Earth. In terms of celestial body interactions, the main factors affecting the Earth's rotation are the Moon and the Sun, as follows: the influence of the Moon, tidal effect. The gravitational force of the Moon on the Earth causes tidal phenomena in the oceans on the Earth. The tidal bulge will move with the rotation of the Earth. Since the Earth's rotation speed is faster than the speed of the Moon's revolution around the Earth, the tidal bulge will have a relative displacement with the position of the Moon, which causes the tidal bulge to produce a tidal friction force on the Earth in the opposite direction of the Earth's rotation. Although this friction is very small, it will continue to work for a long time and will gradually consume the energy of the Earth's rotation, causing the Earth's rotation speed to gradually slow down. According to scientific research, the current rotation speed of the Earth will slow down by about 1.6 milliseconds every 100 years. Stabilizing the tilt of the Earth's axis. The existence of the Moon stabilizes the Earth's rotation axis. If there is no Moon, the tilt angle of the Earth's rotation axis may change greatly, and this change will affect the Earth's climate and ecological environment. The gravitational force of the Moon keeps the Earth's rotation axis at a relatively stable tilt angle, which is of great significance to the birth and development of life on Earth. The influence of the Sun, gravitational effect. The gravitational force of the Sun produces tidal force on the Earth, but the tidal effect of the Sun on the Earth is smaller than that of the Moon, about half of the tidal force of the Moon. The tidal force of the Sun will also have a certain impact on the rotation of the Earth. Although this impact is relatively weak, it will also slow down the rotation speed of the Earth to a certain extent. The influence of solar wind. Solar wind is a high-speed charged particle stream blowing from the surface of the Sun. When the solar wind interacts with the Earth's magnetic field, it generates electric currents in the Earth's upper atmosphere. These currents generate a weak magnetic field, which interacts with the Earth's inherent magnetic field and may have a certain impact on the Earth's rotation. However, this effect is very small and has not yet been fully studied and confirmed. The Earth's rotation has many important effects on the Earth itself. 1. Geography and topography. Equatorial bulge and polar flattening. Due to the centrifugal force generated by the Earth's rotation, the Earth is slightly bulged at the equator and the poles are relatively flat. This shape affects the Earth's gravity distribution. The gravitational acceleration near the equator is relatively small, while the gravitational acceleration in the polar regions is relatively large. This shape feature also affects the distribution of the Earth's oceans, making the sea level near the equator relatively high and the sea level in the polar regions relatively low. One of the driving forces of plate movement. Although the main driving force of plate movement is considered to be mantle convection, the centrifugal force and Coriolis force generated by the Earth's rotation may also have a certain impact on plate movement. For example, centrifugal force may affect the direction and speed of plate movement on the surface of the Earth, while Coriolis force will deflect the direction of plate movement. Although this effect is relatively small, it may have an important impact on the distribution and evolution of plates on a long geological timescale. 2. Atmospheric circulation. Coriolis force and wind direction. The Coriolis force generated by the rotation of the Earth deflects the wind direction in atmospheric movement. In the northern hemisphere, the airflow deflects to the right. In the southern hemisphere, the airflow deflects to the left. This deflection leads to the formation of atmospheric circulation, such as the trade wind belt in low latitudes, the westerly belt in mid-latitudes, and the polar easterly belt in high latitudes. Atmospheric circulation plays a vital role in the Earth's climate and weather system, which determines the temperature, precipitation, and climate characteristics of different regions. Formation and evolution of weather systems. Atmospheric circulation under the influence of the Earth's rotation also leads to the formation and evolution of various weather systems, such as cyclones and anticyclones. Cyclones are low-pressure centers where air rotates counterclockwise, in the northern hemisphere, or clockwise, in the southern hemisphere, under the action of the Coriolis force. Anticyclones are high-pressure centers, where the air rotates in the opposite direction to that of cyclones. These weather systems bring about different weather phenomena, such as rainfall, storms, and clear weather, which have a significant impact on human production, life, and the ecological environment. 3. Ocean circulation. Coriolis force and ocean current direction. Similar to atmospheric circulation, the Coriolis force generated by the rotation of the Earth also affects ocean circulation. Ocean currents are deflected under the action of the Coriolis force, forming a global ocean circulation system. For example, the North Atlantic warm current is formed under the combined action of factors such as the rotation of the Earth and ocean topography. Ocean circulation plays an important role in regulating the Earth's climate. It transports heat from low-latitude areas to high-latitude areas and balances the global climate. Impact on marine ecosystems. Ocean circulation affects the distribution of nutrients in the ocean, the migration of marine life, and the living environment. For example, upwelling areas are usually rich in nutrients and attract a large number of marine life. Changes in ocean circulation may cause an imbalance in the marine ecosystem and affect the survival and reproduction of marine life. 4. Earth's magnetic field. Generator effect and magnetic field generation. The rotation of the Earth causes the conductive materials, such as liquid iron, inside the Earth to move, and this movement interacts with the Earth's magnetic field to generate the Earth's magnetic field. The Earth's magnetic field plays an important protective role for life on Earth. It can block the invasion of solar wind and cosmic rays and protect the organisms on Earth from high-energy particles. Relationship between magnetic field changes and Earth's rotation. The Earth's magnetic field is not constant. It changes over time. Some studies have shown that changes in the Earth's magnetic field may be related to changes in the speed of the Earth's rotation. For example, at some times in the history of the Earth, the speed of the Earth's rotation may have changed, which may have led to changes in the intensity and direction of the Earth's magnetic field. 5. Life and ecology. Day and night alternation and biological rhythm. The rotation of the Earth produces the phenomenon of day and night alternation, which has a vital impact on life on Earth. The physiological rhythms, behavioral patterns, etc. of organisms are closely related to the day and night alternation. For example, the growth, reproduction, migration, and other behaviors of many animals and plants are regulated by the circadian rhythm. Day and night alternation also affects photosynthesis and respiration on the Earth, and plays an important role in the energy flow and material circulation of the ecosystem. Climate stability and ecological balance. The atmospheric circulation and ocean circulation under the influence of the Earth's rotation regulate the Earth's climate, making the Earth's climate relatively stable. This stable climate provides a suitable living environment for life on Earth and promotes the balance and development of the ecosystem. If the Earth's rotation speed changes drastically, it may lead to climate instability and cause serious damage to the ecosystem. In the vast universe, the Earth is like a bright blue pearl, continuously rotating, interpreting endless magic and mystery. Our exploration of the Earth's rotational force seems to be an endless scientific journey. From the angular momentum in the early formation of the Earth to the subtle influence of celestial body interactions, every discovery allows us to have a deeper understanding of this planet on which we depend for survival. However, there are still many unknowns waiting for us to uncover, and future research may bring more unexpected new discoveries. The rotation of the Earth not only shapes the colorful natural landscapes and miracles of life on Earth, but also provides endless inspiration for human scientific exploration. It reminds us that the universe is so vast and mysterious, and we are just tiny explorers in it. But it is this curiosity and spirit of exploration of the unknown that drives us to keep moving forward to seek more answers to the mysteries of the Earth's rotation and the universe. Let us continue to explore on the road of science with awe of the universe and a thirst for knowledge, looking forward to the next amazing discovery, and contribute our wisdom and strength to unraveling the mystery of the Earth's rotation. Because, in this universe full of miracles, the story of the Earth's rotation will never end, and it will continue to lead us to deeper unknown areas.